questions.
Well, a project is never done until we've done it, right? So, okay. So, tell me about layers, because you say that you know, in a a neuron will not produce any output unless you know the aggregate is reached a certain level, right?
Depending on the function, let's say if you use the hard limiting threshold, you say, is activation greater than my threshold?
Yeah. So you have the same kind of property for every layer, right? Because you need to choose a way so that you make sure that the layer does produce something, right? Otherwise, the next layer does nothing.
For the whole net that we have seen just now, they all use the same function. Let's
so
stick
so
with
every
sigma.
layer you have to make sure there's an output, there's an output, there's an output.
Yes.
Okay.
Because they need to feed forward to the next one.
Okay.
So you say, okay, I'm going to use the sigmoid function. All layers, all nodes use that function, and then they evaluate their outputs, and then you push them.
So is that not a problem? Because let's say you want to kind of compose these functions, right? At the moment you're doing one function like or not, but you're going to do no by composing or and not. You can't really do that because you don't know how to use the weight.
But you don't need to know the weights. You just randomize them between 0 and 1.
Yeah, but then you may not. I mean, what I mean is there doesn't seem to be any kind of algebra of
how to say,
combining outputs and inputs. This is just a very abstract question, so don't worry.
No. But I'm trying to understand the question. Like, you said you have a function.
Yeah.
If you know what you input and if you know what you should expect, then it can learn.
But supposing I want to compose it with another function.
If you know the general result, like general function, I mean, you need to
we know because combining you know not and or is no. We know that, right? But we don't want to do a no function. We want to do or and then no, and then we want to put them together. So you combining the layers, but combining layers that way doesn't seem to work, right?
More like the whole, like you could combine, you could create one NOR and one whatever else, and then you can take out of that and put it here and still get the same result that you want.
Well, I'm asking, will you though? Because
I mean, that's not my aim, but that will be achieved. I mean,
because the output is a value, but the input is multiple. You know what I mean? The two don't combine together in an algebraic way. Does that make any sense to you?
Do I understand correctly? Imagine you have one, you want to train and then not, so you get a NAND, like not AND.
But I want to combine them together into one network. That doesn't seem to be possible.
Well, okay.
Yeah.
You probably need to combine two networks. That one does the AND, the other one does the NOT, and you end up with the.
But you cannot combine them end to end, right? Because you don't have the right inputs for the second function. Is that right? That's what I see from your pictures.
If you don't have the targets, yes, I mean, you can't.
Okay.
Okay. I don't know if that makes sense to you.
No, I'm just thinking, you know, in terms of function composition, it's an algebra, but because the way neural net, the way you explain it, the way neural net computes the function, doesn't seem to be algebraic at all.
I mean, like the features that Vlad was showing, its height or whatever. You know, if you expect the dancer to be like 2 meters tall or muscular guy, you can say, okay, I want this and match it, but that's my target. You should have a target in a supervised learning.
I think maybe we're not on the same page. Never mind, doesn't matter.
Maybe.
So, just one question on back propagation. You get a very clear explanation of back propagation.
I'm glad to hear that.
Yeah. So, why is it that you need to do it multiple times? Why is it that one time backwards is not enough? Why do you have to keep repeating?
Like every cycle, you
Yeah.
just change the error once a little bit, and you check in the next cycle whether the changes that you have made are actually the right ones. You compare, and then you try to reduce the error.
So the right ones for the particular classifier, particular example.
Let's say x squared, you put 2 and 2
So
squared.
if you do back propagation for, let's say, for dancer, like black example, then your net will always recognize dancer? No, not always. It's just for that particular test, you will say this is the dancer. Is that right?
I'm not sure.
I mean, because your backward propagation is always using a particular input, isn't it? So once you do back propagation for that input, your net will always correctly identify that. Is that right?
Yes.
Yeah. So because there are many other inputs, you need to train them on all of them.
Yeah.
Okay.
Like unlike well, if it's something like XOR, you might have some trouble, getting stuck and getting the wrong output. But there are like ways to overcome that.
What's special about XOR? Because it's actually a composition of function.
more like when you initialize the weights wrongly, when they are in the wrong, like when they end up in the wrong side of the thing, like of the graph, let's say, as you said, as Vlad said, like you descend towards the wrong minimum error. Like you're not aware of the better solution. You just find the nearest one, kind of thing.
Why does XOR have this particular property?
I don't know that.
Okay. It could be that XOR is a combination of two functions.
Well, it is.
Anyway, okay, I'll stop there. Thank you.
Right, I'm just going to ask you one question. Which has been the most challenging part of the project so far?
Well, I can answer in two ways. One is like the not inverter, because I had no idea when I started what I was doing, so I probably spent a lot of time. Compared to back propagation, where I was like, okay, I know actually how things work. In terms of challenge, of course, the last thing is more challenging than the first one.
Okay, right. We all happy? Any questions? Right. I'm going to say thank you.